Hello all and welcome to Pre-Calculus. Okay, and so let us begin. Pre-cal. All right, so this video is going to be, hopefully, fairly simple. And really all I want to do is introduce a couple of notations. The main point of this video will be interval notation. Interval notation is usually new to a pre-calculus student, but it doesn't have to be new. Maybe you've seen it before. And over here is called set notation. Some people call it set builder notation, but typically in academic circles, a lot of people just call it set notation. And these are just ways to refer to a set of numbers. So for example, over here, well, actually, let's start here. Let's start above all this stuff. Let's say we have the following statement, okay? X is less than or equal to 4, okay? So the question is what is X allowed to be? Well, X can be any number that is smaller than 4 or the same as 4, okay? And over here in set builder notation, let me make sure that I'm not messing this up here. Yeah, so what we do is we put the whole thing in braces. So to write this statement in set builder notation, we say it like this: it's the set of, that's how you read this left brace, the set of all X, and then such that. So this vertical line is such that. And then we can just say X is less than or equal to 4. So it's the set of all X's such that X is less than or equal to 4. And then we have to say, well, X is an element of, and then the real numbers. So the fancy R just means real numbers. And of course, the real numbers is any number that you can possibly think of that is not imaginary or complex. Over here in interval notation, we can write the same statement this way. So if X is less than 4, or less than or equal to 4, then that means that the highest value that X can be is 4. And then it can be any number less than 4. So we write it this way in interval notation: negative infinity to 4. So the way interval notation works all the time is you have, think about your real number line. All the way over here to the right is positive infinity. All the way here to the left is negative infinity. And of course, right in the middle between those two is going to be 0. And I like to think about interval notation. I like to think about this number line from left to right. Okay? All right, so that's sort of the first example for this. Let's look at a couple more. Let's say we have the following statement: X is greater than 5. Okay? So in set notation, we would say that this is the set of all X's such that X is bigger than 5 and X is an element of the real numbers. Unless otherwise specified, we're going to be working with real numbers. So this is in set notation. And then in interval notation, we're talking about all the numbers bigger than 5. Now be careful, this one does not have greater than or equal to, it's just greater than. So that means we cannot include the number 5. And if we look up here, I used a bracket to indicate that we could in fact use 4, because the first statement was that x is less than or equal to 4. And so the way that we exclude 5, because we don't want 5, but we do want 5.00000000001, for example, is we use parentheses. 5 to infinity, like this. Just so you know, infinity and negative infinity always get parentheses because you cannot put positive or negative infinity inside of a container. Infinity and negative infinity are larger than any real number in the world, and so it always gets a parenthesis. Okay, let's look at a couple more statements here. Let's say we have this one. So here we have negative 19 is less than x, and x is less than or equal to 10. Okay, and again, this is just all about notation. Let's read this one step at a time. The first thing says that negative 19 is less than x. Another way of saying that is that x is bigger than negative 19. So whenever you have an inequality, you can read it from left to right, or you can read it from right to left. So if I read it this way, I'm saying negative 19 is less than x. If I read it this way, I'm saying x is, and then this is opening toward x. So x is greater than negative 19. Okay, so there's that portion of the statement. Now let's look at the other part. This is a compound inequality. This here, this says x is less than or equal to 10. And another way of saying this, if we read it this way, is we're saying that 10 is greater than or equal to x. So again, you can read it either way. All right. Now, let's look at our set notation. Yeah. So to write this in set notation, it's basically exactly what it is already. Open the brace, set of alt x such that negative 19 is less than x, less than or equal to 10. And then we have the comma. Yeah. That x is an element of the real numbers. Over here, for interval, well, first let's look at here. This is saying that x is bigger than negative 19. So we're going to have parenthesis negative 19 to, and then positive 10. X is less than or equal to positive 10. So this is called a half open interval. Okay, and it's because the parenthesis here is on the left. And the parenthesis means open. And, again, if you think about infinity, infinity cannot be contained. You cannot enclose infinity in a container. So that's why it's always open. That's why the infinity always gets a parenthesis. And if we go up here, this is a completely open interval. This is half open because the first parenthesis is open. Okay. Now let's compare that with this. Let's say we have this instead. I'm going to keep everything basically the same. Basically the same, but a little different, right? So set builder notation is going to look basically exactly the same as it did before, except swap these. Interval notation is going to look like this. So the negative 19 has equality. Anytime you see equality, it gets a bracket. And then we have no equality here, so we get a parenthesis. And so this is called a half closed interval, is what this is called. Half closed interval. It's all about whatever the first thing is doing. If the first symbol there is a bracket, then it's either half closed or completely closed. And then if the first symbol there is a parenthesis, then it's either half open or completely open. Okay? Yeah, just for good measure. There we go. What else do we got? You know, well, okay. I guess we don't have we haven't used a closed interval yet. So here we have equality on both. So in interval notation, this will be negative 300, comma 100 with brackets, and then set builder. Oops. All right. So there we go. So, you know. So x is any number between negative 300 and 100, and this is saying the set of all x such that x is real and x is less than 100 and bigger than negative 300. So it's all the numbers including negative 300 and 100. All right, so I think that's about it for this video. I just wanted to introduce you to interval and set builder notation.